طيب بسم الله الرحمن الرحيم. النهارده هنمسك الباست تيب اللي هي كابلة للاف ار كيو، وهنحاول نحل الأسئلة كلها، نشرح شوية بديتيل، في نفس الوقت نحاول نخلص الامتحان كله ونشوف هنقدر نخلصه في وقت قد إيه. نقول بسم الله الرحمن الرحيم. We start ونشوف الناس الثانية when they join, but we will start right now. So this is the first question. The student is given the task of determining the I minus content of tablets that contain potassium iodide and inert water-soluble sugar as below. So what does my tablet contain? التابلت بتاعتي عبارة عن بوتاسيوم ايودايد. دي تابلتس بيكون عند الناس اللي عندهم high blood pressure محتاجين بوتاسيوم. And it is containing inert water-soluble as sugar. Inert means it does not do anything except increasing the mass of this tablet. So tablet contains potassium iodide plus sugar، والشوجر دوت ملوش أي فايدة غير إن هو بيكبر الحجم بتاع التابلت. A tablet is dissolved in 50. I took one tablet and dissolved it in 50 ml water of distilled water, and an excess of 0.20 molar lead nitrate equals is added to the solution. A yellow precipitate forms, which is then filtered, used and dried. The data from the experiment are shown in the table above. يقول لي انت عندك mass of potassium iodide 0.425. هذه التابلتس كلها لما حطيتها on the balance the whole tablet is 0.425 grams. And the mass of the truly dried filter paper alone without putting anything on it is 1.462. The mass of the filter paper plus the precipitate after drying is 1.775. So he said for the chemical reaction that takes place on the precipitate forms, we write a balanced net ionic equation for the reaction. But precipitate of what? He reacted the potassium nitrate with lead, the potassium iodide. He reacted the potassium iodide plus lead nitrate, and you won't have to write the equation for that. And said write a balanced, and it should be a net ionic equation for the reaction. So the reaction occurs between the lead from the lead nitrate and the iodide from the potassium iodide tablets. So this is the reaction. Part of the product will be from the iodide, and part will be from the lead that's coming from the lead nitrate, the substance that I added to the tablets. What they will form? They will form a precipitate. Your precipitate dot is lead iodide. So since lead always we remember as +2, about the +2 because here is coming 2 and iodide is -1, so it will be lead iodide. This is a precipitate, a solid precipitate. So this is a solid precipitate. It does not dissolve because we know that iodides are soluble except for some of the ions like the silver, like the mercury, like the lead. Then this is an aqueous, it's dissolving, and this is aqueous. The net ionic equation will show us only the ions that come from the solid product. What is the solid product? Lead iodide. So I will just write the things that form the lead iodide, not something else. The spectator ions like the potassium and the nitrate are not mentioned. So I will cancel out the potassium and cancel out the nitrate. I don't show them. Why? I don't show them in the net ionic equation because they don't change during the reaction. They come in the reaction the same way they are in the products. So I will leave them out. Some students, they will put the potassium nitrate in the ionic and say this is net ionic. Of course not. If you write the potassium and lead and iodide and nitrate in the equation and say that this is a net ionic equation, of course this is wrong because you have included the spectator ions. We should not include the spectator ions and focus only on the ions which changes its state. It was aqueous here, become aqueous here. It was solid here. It was aqueous here, become solid here. So this one was aqueous and become solid, and this aqueous becomes solid. But what about the lead? The lead, sorry, what about the potassium? The potassium was aqueous, and it will stay aqueous also. It will stay aqueous also. So I don't write it. What about the nitrate? The nitrate was aqueous, and here the nitrate is aqueous, so they are spectator. Whatever did not change, I will call it the spectator ions, and I don't write it down. Okay, the second part is asking me explain why the reaction is best represented by net ionic equation. انت ليه بتكتب الايكويشن اساسا بالنت ionic equation? Why you are writing like summarize it like that? I will tell him because the net ionic equation focus only on the ions that's involved in the precipitate. هيما بس they are the only the ones that form the lead iodide. طب تعملي تسهيل الايكويشن. It simplifies the equation. اشيل الحاجات اللي ملهاش لازمه. I remove anything that's not included and does not make any sense. So lead Pb2 plus iodide. 2 iodide forms the lead iodide solid. يعني بتبسط لي الايكويشن. Simplifies the equation by removing the spectator ions. So I can easily see what's happening in the reaction. Give me a second. I'll check the people who did not come until now. Why they didn't join? Okay, so let's see the next question. The next part is explain the purpose of drying and weighing the filtered paper with the precipitate 3 times. He said, I did not just wash, I did not wash it only, I just washed it and dried, and I dried the filter paper with the precipitate 3 times. So every time I'm drying and weighing, every time I'm drying and weighing, every time I'm drying, I weigh. Why I'm doing this? Why I'm repeatedly doing this? The reason is that I am drying the filter paper and the precipitate multiple times to make sure that the water is completely removed. I want this to be the precipitate and the filter paper and no water. So this is the precipitate of lead iodide that's formed and the filter paper only. I don't want any water to be in there. That's why I make the drying 3 times and I weigh every time to make sure that the mass stops changing. Once the mass stops changing, it's not changing like I see here. It became constant. It became 1669 and then become 1698. This is very small change, so I will consider that it becomes stable mass. Once the mass is not changing anymore, I will know that it's fully dry. There is no water. But what's important? Why you remove all the water? Why you are not keeping any water inside? Because if you left any water inside, it will increase your calculations. It will increase the mass. Instead of being weighing only lead iodide, you will be actually weighing the lead iodide plus the water that you did not dry correctly. So the student might not understand why the mass is constant. That when I dry many times, I remove any moisture, any residue moisture that's remaining, which will otherwise add to the weight. So instead of getting the mass as 100, I will get 101. And I think that correct. This is the correct mass. No, actually, it's not the correct mass. This 1 gram is water. This 1 gram is water that has not been removed. This 1 gram is water that has not been removed. Okay. So let's see the next part C. So we are still in question number 1. So part C, in the filtrate solution, this is a very important question. Is K plus larger than, less than, or equal to nitrate ions? So we did write the equation. احنا قلنا equation lead that iodide give me lead iodide, and this is the equation that we wrote. But he's asking me which is greater. Is it the concentration of the potassium less than or equal to nitrate? Because when you filtered, what did you filter? You had a precipitate, right? So when you added the lead to nitrate plus the potassium iodide, you formed the lead iodide salt. So this is the one that stayed as a residue here. This is the one that stayed as a residue here. And then you have a filtrate. What is in the filtrate? The potassium nitrate. So potassium nitrate is inside the filtrate. This is the one that we canceled from the equation, and we said because it is what? and then K, because it is spectator ions. But why? I will see ions, I see here potassium and nitrate. He is asking me, هل النمبر of ions or concentration of this one is equal, or this is more, or this is more, and you have to justify. In the solution that I have here, in the potassium nitrate that I have in the filtrate here, the potassium actually is less than the nitrate. The potassium will be not equal to and not more than. It will be less than nitrate. But why is that? Mister, when you get the number of moles, lead nitrate solution was added in excess. So you added an excess of this one to your tablets. At the beginning of the question, we had the tablets and we dissolve it in excess of the lead nitrate. Where did you get this from? Here, it's written here. You dissolve it in excess of lead nitrate. So if you dissolve it in excess nitrate, you wanted to make all the tablet dissolve. That's why you put excess, because you want to make all the tablet dissolve. ما تسيبش حاجة من الtablet. Don't leave anything which is not dissolved. As a result, there will be more nitrate ions than the potassium ions, because the nitrate came from this one and it is coming from excess, while potassium was the limiting reagent. So this means, Mr. Nitrate is coming from excess reagent. Because then after I finish the precipitation, there will be more nitrate. But the potassium is coming from a limiting reagent, which is the potassium iodide. That's why the concentration of nitrate is more than the concentration of potassium again, because the nitrate concentration is coming from a reagent which was in excess. That's the lead nitrate. While the potassium iodide was the reagent that was in limiting reagent. That's why it is less amount. Okay, so بعض الستودنتس بيقولوا مستر أنا الريشيو عندي هنا 1 to 1, so they say this is K and this is NO3, so the ratio is 1 to 1, so the number of moles is correct. The number of moles is 1 to 1 in the compound if there is no excess. لو أنت كنت حاطط ده قد ده, if you put the same number of moles ratio 1 to 2 كان هيطلع لك 1 to 1, but you added excess from this one. So if you added excess from this one of course will be more than the potassium. So this is more than the potassium before you are putting excess from. Right. Now he is asking me to find after the equation, to find the calculation. What is the number of moles of the precipitate that's produced? So what is the number of moles of precipitate that's produced? خلينا نجيب الأرقام تاني معانا. Let's bring the numbers again that we have at the beginning and the equation. This is the numbers that we had at the beginning, so we can use them. And the equation is lead plus iodide give me lead iodide, and this is my equation. So I need to find the number of moles of precipitate that's produced in the experiment. Mister, what is the mass first of the lead iodide? Because until now I don't have the mass of the lead iodide alone. The lead iodide, which is the precipitate, I don't have it here. He gave me the mass of the filter paper plus the precipitate after the third drying, but I don't have the mass of lead iodide. So what do? I do the filter paper mass plus el precipitate mass minus the mass of the filter paper. So if you do like that, you cancel the filter paper from the filter paper mass, you get the mass of the precipitate alone. So it will be 1.698. This is the latest mass that you get after you can make complete drying, and then you minus it from the precipitate, from the filter paper alone, which is 1.462. 1.462, you get 0.236 grams. This is your mass. Okay, if you have the mass and you need the number of moles, what do? The triangle tells me that the number of moles is equal to mass over molar mass. So the mass is 0.236, and the molar mass of lead iodide you have to put in the periodic table. So in the periodic table it is 461. So mass equal to number of moles multiplied by the molar mass. Number of moles is equal to mass over the molar mass. So 0.236 divided by 461 gram per mole, which is the molar mass of the lead iodide. نخش على periodic table, I will see it's lead and 2 iodides 461. So you will get almost 0.0000512 moles. How many significant figures عندي هنا؟ عندي 1, 2, 3, 4. So I need to put 4 significant figures. That's 0.0005120. So what will be the latest answer for the calculation? It's equal to 5. خلينا نبص إذا كان في أرقام تانية أصغر. أنا عندي هنا 3 significant figures. أنا عندي هنا 4 significant figures, but here I have 3 significant figures. So I can just make it either 0.0000512 or say 5.12 10 to the power of 1, 2, 3, 4, negative 4. I can just say 5.12 multiplied 10 to the power of negative 4 moles of lead iodide. So simply, Mr. You find the mass, very easy, and you divide it by the molar mass. When you divided the mass by the molar mass, you got the number of moles of the precipitate that's formed in the experiment. The next question, he's saying, what is the mass percentage of iodide in the tablet? So how, which means how much the iodide presents, how much the iodide represents from the total mass of the tablet. Iodide mass out of the total mass of the tablet. Mr. The number of moles of iodide is equal to what? This is where the mistakes happen. This is where the most of the mistakes happen. الناس بتقول this is the number of moles of lead, the mass of lead iodide. This is the number of moles of lead iodide. 5.2 multiplied 10 to the power of negative 4. So number of moles of iodide is 5.12 to 10 to the power of negative 4. Oh, you forgot something very important, which is that when the lead iodide actually breaks down, it forms 2 of the iodide ions. It does not form 1. So the ratio is 1 to 1 to 2. So if you have 5.12 multiplied 10 to the power of negative 4 moles from the lead iodide, this number has to be multiplied by 2. So actually you have iodide moles is equal to the moles of the lead iodide multiplied by 2, which is 1.02 multiplied 10 to the power of negative 3. So this is the number of moles of the iodide, and you can find the mass of the iodide now the same way you found the moles of the lead iodide from its mass. You can now change the mass of the iodide, the number of moles of iodide to its mass. So how do I get the mass of it? The mass is equal to number of moles multiplied by molar mass. So number of moles is 1.02 multiplied 10 to the power of negative 3. And the molar mass of iodide is, it's a periodic table here. Okay, I'll just try to get the number. The number is so that's 126.91 grams per mole. When you multiply these two together, you get the mass of the iodide, which is 0.130 grams. خلاص يا مستر بقى عندي الماس بتاع الايودايد. عايز اشوف الايودايد من التوتال تابلت بقى كام؟ يعني الايودايد you need to find the iodide of the total tablet to find the percentage mass. So percentage mass of iodide is equal to the mass of the iodide divided by the total mass of the tablet as it is. Take care, it's not in the potassium iodide, it's in the total mass, because I got too many students dividing the mass of the iodide divided the potassium iodide. No, it's divided by the total mass. So 0.130, the total mass of the tablet is 0.425, and then multiplied by 100. So 0. Divided by 0.425, and then multiply this by 100, you will get the mass percentage, which is equal to 30.6%. So a percentage, tell me how much of the tablet mass is due to the iodide. If you want to do the same thing for the potassium, you will divide the mass of the potassium by the total mass of the tablet and so on. Again, I'm saying most of the students make the mistake of forgetting to multiply the number of moles of the lead iodide by 2. If you don't multiply, then you are ignoring this ratio. You are as if you are saying it is lead iodide 1 and 1. No, it's 2. Okay, the part F of this question is asking us, this is part F. In another trial, the student tried to make the same experiments again, but instead of dissolving the tablet in 55 ml water, instead putting the tablet in 55 ml water, he just put it in 50 ml water. خد التابلت and put it in 50 ml instead of 55. Is he going to get the same mass percent of iodide, the same exactly like the previous student or not? And if you say why, you have to justify also. So I added lead in excess. If you remember, I added lead nitrate in excess, right? And potassium iodide tablets was the limiting reagent. So since this one means it's in excess, it means that all the iodide ions inside the tablet was completely reacted. All the iodide ions changed into precipitate, solid, and completely reacted. There is no excess from the iodide. So the extra water that you are putting does not change how much the iodide ends up. So if انت عمال تحط you are okay, I hope my sound is still clear. Okay, so all the amount that you are putting from water does not make any change. Why? Because when you make drying, انت هتعمل drying, you will remove any excess water. So instead of putting 50, if you remember, we make full drying, صح? We make full drying in order to remove the water. So if you put 50 ml and then dry, you will remove the excess. But if you put 55 and dry, you will get the same constant mass at the end. But if you put 1000 ml, it doesn't matter. So the drying process will remove any additional water. And at the end, the final dried precipitate will be the same. So the final mass of lead iodide that we calculated here will be the same. And the final percentage will be the same. So the amount of water does not change the amount of lead iodide. إمتى تتغير results? When does the results change? When the content of the iodide inside the tablet changes. لو انا جبت تابلت، التابلت ديت فيها بدل ما يكون فيها زي المره اللي فاتت الانسر 30%، لا نص الحبايه ايودايد. So instead of the tablet is 30% only iodide، لا بقت عندها نص 50% iodide. In this case the percentage is going to change. لكن انا دوبتها في 100، دوبتها في 200، دوبتها في 500، it does not make any difference. زي بالظبط لما واحد has headache. If you have headache and then you took 2 tablets of Panadol because you have headache, وبعدين شربت 1 glass of water بعديهم، وبعدين another student has headache so he took 2 tablets of Panadol and drink 5 cups of water. Is there any difference? There is no difference. If you took 1 glass of water and you took 5 glasses of water, you didn't do anything. That here is still 2 tablets and here still 2 tablets. So here also, if you add more water, you are not making any difference. You are still having the same concentration. As long as the reactants are still in excess and all the iodide reactants are reacted. بعض الناس would think that adding water will dilute the reaction, so decrease the amount of the precipitate. No. The limiting factor هو iodide, not the water volume. The limiting reagent هو iodide. So this is the one that will make the difference. This is the one that will make the difference. Okay. معظم الناس مش بتفهم الحتة دي كويس. So we are going to repeat it again. We are going to repeat it again. ليه يا مستر؟ الاديشن الجزء دوت براكتيكال ولازم يكون شغال براكتيكال كتير. You have to make a lot of practical work in order to understand how this is happening correctly. So I will say again, why adding water does not make any change in the final concentration or the final mass percent. I will tell you. The original setup, I put the student dissolved in 50 ml. The tablet contains iodide ions, which solution has lead iodide ions from the lead nitrate. When I add excess water, actually what I am saying when I'm adding excess water is that lead is added in excess. So if I added excess water means I'm adding excess. أنا كان عندي tablet. So when بقول lead is added in excess معنى ذلك there is more than enough lead to react with all the iodide. أنا عندي iodide will finish and I have more than needed. So I will be having more than needed to react with all the iodide, and iodide is empty, so it will finish. So no matter how much water you use, there is already enough lead to make sure that all iodide will react. So if you add more water, you add less water, it is still the same. طيب لما بستخدم more water, if I use more water, if the student dissolves in 55 instead of 50, the only difference is that the solution is more diluted before the reaction happens. But once the reaction goes to completion and is finished, there is still plenty of lead to react with all the iodide ions. The extra water will not make any change in the precipitation. Type. Why the mass percentage does not change at the end? Because mass percentage depend on how much iodide tablet in the tablet compared to the total mass of the tablet. Since all iodide reacts and forms solids, extra water is filtered out, the extra water, ممكن أقول بقى دي الإجابة. This is the summary. I will say that since all iodide reacts and forms solid and all excess water is filtered out, the final dried precipitate will have the same weight. Right. Let's see the last part, part G, saying that a student in another lab made the same experiment to determine the amount of the content of iodide in potassium iodide. بس ما عندوش excess من lead nitrate. He doesn't have lead nitrate in excess. He has small amount. So he decided that instead of making the reaction between lead nitrate and the potassium iodide in the tap, he found in the lab a lot of silver nitrate excess. So he said, I will use the silver nitrate instead of using the potassium nitrate. This time with AgNO3 because it's not +2, it's +1. And he reacted the potassium iodide. And he found that the value of the KSP of AgI is 8.5. هل أنا مقدر أعرف الكلام ده؟ Can I do this? Can I change the lead nitrate and put silver nitrate instead of it? And the reaction and calculation will be correct or not? طبعا أيوه. Because the silver nitrate has a very small KSP, and this very small, it's 8.5 to 10 to the power of -6, 17. There is a lot of zeros here. 0.0000000000085. So it's very small. على ذلك إن هو بيعمل إيه precipitate. So it will make a precipitate. When is the problem? إمتى أقول ما ينفعش? I will say it cannot be used. إمتى? When there is no precipitate formula. لما يكون ال KSP بتاعي is big number. So it's a big number, not a small number. It means that there is very big solubility. This means the substance will not dissolve. So since it has very low solubility, if I use silver nitrate بدل lead nitrate, still I will form a iodide precipitate. الناس تقولها ايه? People think that if I change it from lead to silver, the reaction is not going to happen. أنا مش مهم عندي أساسا الليد ولا السيلفر. المهم عندي الايودايد اللي موجود في التابلت. The most important thing is that the iodide in the tablet is precipitated. والله you make precipitation with lead, you make it with silver, I don't care. And at the end I will calculate the percentage of iodide out of the whole tablet. So I don't care who is with the iodide. I don't care who is with the iodide. Is it potassium? Is it lead? I don't care. Okay, the most difficult part of this question is the last part. وبرضه I'm saying this is because most of the people don't do enough practical by their hands. So you will not know this until you do a lot of practical. The student only has access to one tablet, KI. ما عندوش غير tablet واحدة بس. And he wants to make the experiment correct. So he doesn't have a lot of tablet to repeat the experiment again. The balance that he use, البالانس اللي هو بيقيس عليه that he measure the masses can be measured to the nearest 0.01. Will the student be able, يعني this is the accuracy of it. This is the accuracy of it, 0.01 grams. Will the student be able to determine the mass of silver iodide produced to 3 significant figures? So I will try to make, did you see here the measurement? I checked the measurement for potassium iodide. It was 0.425 when I used lead. So here how many significant figures? 3. So he is asking me, لو أنا ما كانش عندي potassium iodide, if I don't have potassium iodide, if I don't have silver lead نيتريت، لو ما عنديش ليد نيتريت وعندي بدل الليد نيتريت انا عايز اعمل المره دي الميجرمنت باستخدام السيلفر ايودايد وعايز اطلع 3 significant figures. هل البالانس التعبان دوت can I use this weak balance to get 3 significant figures? Yes or no? The balance اقصى accuracy ليه is 0.01. So it cannot give enough precision. ما اقدرش اجيب اكتر من كده. اي حاجه اقل من 1 جرام مش هتجيبها. اي حاجه اقل من 1 جرام مثلا if the AGI precipitate comes 0.47 خلاص 0.47 ما اقدر يعني ما اقدرش the apparatus will not tell me is it 0.471 or 0.472 or 0.473. Why? Its accuracy does not reach this amount. I can tell you that it is 0.47. زي ما يكون واحد بيوزن نفسه على الميزان في البيت والميزان is a very old balance, so it will tell you your weight is 70 kilogram. It will not be مرة تقيسه يطلع لك 70، مرة تقيسه يطلع لك 71، مرة تقيسه يطلع لك 73. Why? The accuracy shows only one significant figure. لكن ده ما بيطلعش مظبوط. But the balance is accurate and has 2 significant figures. هيطلع كل مرة 72. 72, 72. The precision is having 2 significant numbers. So here I have 2 significant numbers and you are asking me to make 3 significant numbers? Of course not. So to report to 3 significant figures, what is the minimum number that I will have? لازم يكون على الأقل عندي 0.001 accuracy. If it is 0.001, okay, but 0.01 is not going to work with me. Let's go for question number 2. Question number 2 is saying that I have here propanoic acid reacting with water and I will form the propanoate and I will form H3O plus. Very good. The propanoic acid is a carboxylic acid. It's from the organic acids and it reacts with water to form the acetate and H3 hydronium ion. At temperature 25, the pH of 50, a sample of 0.20 molar is 2.79. يبقى أنا عندي sample من ال propanoic acid. I have a sample from the propanoic acid. Let me lock this so it doesn't move. Its pH, its concentration is 0.20 and its volume is 50 and its pH is 2.75. I need to find a Bronsted-Lowry conjugate acid and Bronsted-Lowry conjugate base. This is very easy, Mr. A Bronsted-Lowry is the one that gives a proton. The Bronsted-Lowry acid is the one that gives the proton to the water. So it formed H3O plus. So this is the acid. Once it loses the protons, it becomes the conjugate base. So this is the acid, this is the conjugate base. And what is the base? This is the base. It accepted the proton. Once it accepts a proton, it forms the conjugate acid. So I can either say CH3, he's saying identify acid base pair واحد بس ما قالش الاثنين. خلاص انا عملت له الاثنين it's okay. If I make both, it's okay. So acid and conjugate base or base and conjugate acid. This is easy. What is the second part? Determine the value of Kp for the propanoic acid. So for the propanoic acid, I need to find Kp. Mister, isn't it supposed to be K? It's Ka? Yes, it is Ka, but I didn't read it well. So find the Ka for the propanoic acid. How do I find the Ka, Mister? Let's find the H plus first. I don't have the H plus. In order to find the Ka, you must at least have the H plus. But I don't have the H plus. I have the pH. Okay. So if you have the pH is equal to 2.79, I will say that the concentration of H plus is equal to 10 to the power of negative 2.79. On the calculator, it will come 1.6 10 to the power of negative 3 molar. حلو يا مستر. So this is 1.6 10 to the power of negative 3. This is the concentration of H plus. طيب دلوقتي I will try to find the relationship between these two. I know that the ratio is 1 to 1. So the ratio of this one to this one is 1 to 1. طيب يبقى أنا I can simply say إيه؟ I can simply say يا مستر ال H plus squared is equal to the radical of Ka multiplied by the initial concentration. Many times we have said that this equation is very, very, very important. Very, very important equation. The Ka, the H plus squared is equal to Ka multiplied. Why this equation is very important? Because it saves me from the pain of making ice table, which I don't need. I will make the ice table and I think I need it, but actually I don't need at all. Why I don't need it? Because this ice table have an acid concentration in which H plus is a negligible amount. So I will just say the Ka, I will square both of them. So H plus, so H plus, here is H plus. So I will square both of them. So H plus squared is equal to Ka multiplied by the concentration of acid. Remember, where did this come from? It's coming from doubling this one. So if you said H plus multiplied by CH3COOH, it is the same as saying H plus squared, right? So it's equal to Mr. Ka multiplied by the concentration of the acid. So you will say that the Ka is equal to the concentration of acid divided by the H plus squared. What is the concentration of the acid, Mr.? Concentration of the original acid is mentioned here as 0.20. And what is the H plus? We just found the H plus, so I will square it. 1.6 multiplied 10 to the power of negative 3 squared. And I will say here 0.20 divided by the, where is the calculator here? So 1.6 multiplied by 10 to the power of negative 3. And I have to square this value. So I will square it and write it down here. It is 2, 5, 6, 1, 2, 3, 4, 5, 6. 6. So it is 2.56. 2.56 multiplied 10 to the power of negative 6. I will take this and then I will divide the 0.20 by it. 0.20 divided by this value. Is it so? Is it correct? Is it correct or we did something wrong? I think we reversed this one. So Ka is equal to, so this one is H plus squared is equal to Ka multiplied by acid. So Ka is, we have reversed this one. H plus is equal to Ka multiplied acid. If you want Ka, Mr., you have to divide the H plus على acid. You see? What a terrible mistake in the exam. What a terrible mistake. We have reversed it, Mr. خليها محطوطة. Let's keep it. Let's keep it to see how many mistakes I have to check for the exam. You see, reverse it. So H plus squared divided by concentration of acid. So it is 1.6. This is wrong, of course. So 1.6 multiplied 10 to the power of negative 3 squared divided by 0.20. The products over the reactants, the products over the reactants, the concentration of the products, which is this one and this one, over the reactants, twice. So 1.6 multiplied 10 to the power of negative 3 divided by 0.2, you will get the answer as 1.3 multiplied 10 to the power of negative 5. This is your Ka value. So Ka is very small value, which means that this is a weak acid. يبقى احنا شغالين صح. Of course, the previous number was a very wrong number. ايه الاخطاء اللي بتحصل هنا تاني؟ الخطأ الاولاني اللي احنا عملناه we reversed the equation. The first mistake we reversed the equation. The second mistake is to forget to reverse. I always see this H plus is equal to Ka multiplied by concentration of acid. Instead H plus square. طبعا ان انا اقعد اعذب نفسي واعمل الايس تيبل it takes too much time to find that I will reach to the same thing. So if you make ice table and then starting ignoring the concentration instead of x multiplied by, so instead of saying 0.20 minus x, which is very small number, I will cancel and put 0.20 from the beginning. That's right. I know it will be the same thing. So I have to save myself with this equation from repeating the ice table in the very weak acid or very weak bases. Okay, number C. There we found the Ka. Okay, this is the answer here as per exam. It's good. 1.3 multiplied 10 to the power of -5. So it's good. Okay, next part is C. For each of the following statements, so this is the next part, determine whether the statement is true or false. In each case, explain the reasoning that supports your answer. We said that a pH of solution prepared by mixing a sample of this propanoic acid with a sample of 0.20 molars sodium hydroxide is 7. Oh, now we jumped deep inside unit 8. So let's see. You want to make a reaction in which there is and sodium hydroxide reacting with a propanoic acid. Mister, when you have a sodium hydroxide with propanoic acid, this means that you are trying to make a buffer, because if there is an excess from this one and limiting amount from this one, you will end with CH3, CH2, COOH plus CH3, CH2, COO minus. And these two together form a buffer. This will not happen except if the number of this one moles is more than the number of this one moles. Because if the number of this one is more than the number of this one, you will be getting an excess فيبقى عندك buffer. لكن if you have the amount of the base or the number of moles more than the number of moles of acid, in this case you don't have a buffer, you have a domination of the hydroxide ions. طب وازاي هحدد يا مستر? How can I determine this? I can just determine this by the I can determine this by the number of moles. So let's go and try to make the number of moles. Just find the number of moles. فهنا قال لي البي اتش هيطلع 7. بس ايه ده انا مش محتاج اعمل calculation يا مستر. I don't even need to make the calculation. It's very good that I have noticed the number, because the number actually is very easy to know, because this is 7 and 7 is usually coming in which kind of titration? In the strong base, strong acid titration. So in the strong base, strong acid titrations, you will be getting a calculation in which there is pH is equal to 7. لكن هنا ده مش strong base, strong acid. This is a strong base with weak acid. So the pH will be less than 7, more than 7, yeah, mister. The pH is going to be more than 7. So without even calculation, I can know that the pH is more than 7 at the equivalence point. So I will say that this is a false answer. So this is false. Why is that, Mr. pH is more than 7? Since this is a titration between, or a reaction between a strong base and a weak acid. Let's remember together the 3 types of salts that are formed. If you are reacting a strong base with a strong acid, you are getting something called a neutral salt, and the pH is equal to 7. The pH of this one is equal to 7. Equal to 7. If you are making a strong base with a weak acid, you are getting a basic salt, and the pH is more than 7. If you are getting a weak base مع strong acid, you will get a acidic salt, and the pH is less than 7. So I didn't need to calculate it, thanks God, that was easy. In the second one, if the pH of hydrochloric acid solution is the same as the pH of propanoic acid, لو, we said if, but of course it's not the same, then the molar concentration of hydrochloric acid solution must be less than the molar concentration of the propanoic acid. Oh, that's a really strange question, but we'll try to see how we can do it. Let's say again, he's saying that if you assume that the number of moles of H plus produced is the same. How did you know that? Because he said the pH of this one is equal to the pH of the HCl is equal to the pH of the propanoic CH3, CH2, COOH. Mister, they will be not never having the same pH. Why? Because this is very strong, give me a lot of H plus, and this is very weak, give me very few H plus. Okay, but I will change the concentration so this happens. So you need to change the concentration. So at the end, you will get the same number of moles of H plus and number of moles or concentration of the H plus from here. Like, what is the number of moles equal to? Equal to the concentration multiplied by the volume. So the molar concentration of nitric acid must be less than the molar concentration of the propanoic acid. Yes or no? طبعا. طبعا. If you are having a smaller concentration of HCl اللي هو already is giving me, of course, it's already giving me a lot of H plus. So I don't need to increase it. I have to decrease the concentration so I get smaller number of H plus. And when I increase this concentration, it will be getting me H plus more. So finally, they will be equal. So finally, will be equal. So what I'm going to tell him, HCl is a strong acid. It completely ionizes, while propanoic acid is a weak acid, so it partially ionizes. In order to get the same concentration of H plus, I should have a higher concentration, a much higher concentration of the propanoic than the concentration of the HCl. So this will make a balance. ده اللي هيعمل البالانس. زي بالظبط ما يكون two people are playing football. عندي محمد صلاح مثلا بيلعب and somebody from Egypt. مش عايزين, we don't need to make fun of anybody, but anybody in playing in the Egyptian Premier League. So Muhammad Salah is playing and he is getting a goal in each match. And this guy, let's say it's any name, he is Ahmed, and he is getting a goal in every 10 matches. And I want at the end of the season for them to be having the same number of goals. Let's say I want this guy to be having 20 goals and this one to be having 20 goals. What should I do? Mister, you have to make this guy play 100 matches, because in the 200 matches, he will be getting 10, 20 goals. He get 10 goals in every match. So in order to get 20, he need to play 200 matches. While I will keep Muhammad Salah at playing 20 matches. You see? Because the production of H plus from this guy or the goals is very small. So you have to increase the number of the matches for his concentration. While this guy, he is very productive. He is having a lot of H plus. That's why you need to decrease the number. So in order to balance them both at 20 goals at the end, the number of matches this guy must be too high compared by the number of matches played by this guy. Okay, the next question is, a student is given the task of determining the concentration of propanoic acid solution of unknown concentration. A 0.173 molar of NaOH is available to use as a titrant. هو عايز يجيب الكونسنتريشن بتاع البروبانويك acid وعنده sodium hydroxide as a titrant. We always said that the titrant is the one that's available in the purette. Don't forget the titrant in the purette. We know its concentration 0.173 molar of sodium hydroxide, and I know that in the flask I have 25 milliliter. No, I have propanoic acid. He got 25 milliliter from it, and after adding an appropriate indicator to the flask, the sodium titrates with 0.173, reaching the end point after 20.52. He found that the volume that he needs to make the titration and the end point is 20.52 of the base solution has been added. Calculate the molarity of the propanoic acid solution. We always said that I must write the reaction so that I will know what is the concentration ratio. So did he give us the reaction? The reaction is given here, the ratio. No, this is CH3CO. So the reaction here is between CH3 and NaOH. So I would have to say that CH3, CH2COOH, which is propanoic acid, reacts with NaOH to form CH3, CH2COONA plus H2O. Very good, Mr. Akun. Number of moles is 1 to 1. So number of moles of this one is equal to number of moles of this one. So C of this one multiplied by V is equal to the concentration of this one multiplied by its volume. What is the concentration of propanoic acid? We don't know. This is the C of acid. I don't know. What is the concentration of the base? He said 0.173. What is the volume of the base? طلع 20.52. What is the volume of the acid? I put it down here. Put it down here. I put it on. So what I did is that I said this is C acid, B acid. This is C base, V base. I said C equal to C multiplied by V over V. I put the V, I move the V here. So 0.173 multiplied by 20.52. This is in milliliter and this is in milliliter. So you need to change it into decimeter cube. I don't need to change it into decimeter cube because I will cancel it out anyway. And this is concentration in molar. So the concentration of acid will come in molar. Let's do the calculation. 0.173. So 0.173 multiplied by 20.52. And then after I don't put the number directly in the division. I will have to get the answer, then divided by 25. 25, that's equal to 0.141. 0.141, and I need 0.141. This is the answer that came to me. And I need to find how many significant figures. So, Mr. I need 1, 2, 3 significant figures, so it will be 0.142. Very, very easy question, very, very direct questions. We hope the questions in the exam come like that. C multiplied by E equal to C multiplied B. He didn't even to make more difficult ratios. He put 1, 2, 1. Okay, type. Next one is the last one in this question. The student is asked to redesign the experiment. He wants to make the experiment again so that to find the concentration of butanoic acid instead of propanoic acid. For butanoic acid, the PE is equal to 4.83. He said that I need different indicator. When I tried to make the experiment, he told me I will do the same thing. I will put the sodium hydroxide at the top, and I will put the acid in the bottom. But he told me, Mister, I cannot use the same indicator, Mister. I have to use a different indicator. Why, Mister? Because the pKa here is very low. It's 4.83. And we said that the type of the indicator depends on the type of the titration that's happening. So if the pKa is very low, so the indicator also has to be in the same range. So the indicator has to be in the same range. The pKa of the propanoic and butanoic are very close. Is this correct? Mister, if the numbers is very close to each other, let's see. The pKa of this one is 4.83. What is the pKa of the first one in B? B. That was A, and that's B. Determine the pKa. Mister, the pKa here we found as 1.3 multiplied 10 to the power of -5 for the propanoic. And this one is for 1.3 to 10 to the power of -5. That was the Ka, Mister, not the pKa. Take care. That was the Ka. So if I want to find the pKa of it, the pKa of this is of propanoic, and this is the butanoic, equal to the negative log of this one. So I will just say the negative log of this one. So I will put 1.3 multiplied by 10 to the power of -5. And then I need to find the negative log of this value. Oh, no, -5. -5, not counting, to the power of -5. And then I need to find the negative log of this one. So the log 10 of this one is equal to what? And what is the negative log of it? Equal to 4.88. Mister, can you see? The pKa was 4.88. And the pKa of the butanoic is 4.83. So butanoic acid is 4.83. Propanoic acid is 4.88. Do you think you need to make a change in the indicator, Mr. If they have the pKa very close to each other, then the equivalence point will be almost the same. So the equivalence point will be almost the same because we know that the pH is equal to the pKa at half equivalence. At half equivalence. So if the pKa is the same, if the pH at the pKa is the same, so most probably the pH or the end point, the pH at the end point, at the equivalence point also will be also very close to each other. That's why I don't need, so I don't need to make a change, and a indicator which is used in the propellant can be the same as the indicator used as in the propanoic. Propanoic and butanoic is the same. So again, I will tell him the reason is that the pKa difference is very small between 4.88 and 4.83. This is 4.88, 4.89, 4.89. I'm very sorry, it's 4.89. So 4.89, still very close difference to each other. فالخلطة اللي بتحصل ايه؟ Most students make this mistake. They think that any small difference, even if it is small difference, will need me to change into a new indicator. Mr. No. If you are looking here in the pH range, this is the volume added from the base, and this is the pH. So I will say this is the reaction. For the first one, the propanoic, it's coming like that. Don't forget, this is strong base, and I'm adding to a weak acid. So it starts at almost 3. ما تنساش تعمل البuffer region. Don't forget the buffer region. It comes up and then it goes like that. So the pH, ال pKa at half equivalence كانت 4.83. يعني let's say this is 4.83 هنا. والتاني is 4.89. 4.89 فوقيه على طول. So the other one is 4.89, just directly above it هنا. Very directly above it. So you will check what is the range of indicators that I can use. It's almost, it is, مش عايز أقول almost, I will not say almost, I will say it is the same range. So it is the same range. Let's see question number 3. Bismillah, we'll just take 2 minutes break first to grab some water and then we'll continue. Okay. Let's say question 3. Apparently, you'll be able to make 3 questions, which is, of course, related to the exam, is very slow, but because we are explaining more, that's why it's taking more time for us. Let's see the last question. We have explained a little bit about the last question last time, if you remember, when we were talking about Unit 9. So we said that a student is given a standard galvanic cell. So this is a normal galvanic cell, or what we call the electrochemical cell, and represented above that has a copper electrode and tin electrode. SN electrode is a tin. As the current flow through the cell, the student determines that the Cu electrode increases in mass. We said that after the experiment is done, or during the experiment is done, the Cu is increasing in mass. So I'm increasing the mass of this one, and the SN electrode decreases in mass. So this one decreases in mass. Identify the electrode at which the oxidation is occurring and explain your reasoning based on the student observation. Which electrode I have oxidation is occurring and which electrode I have oxidation in the reduction. If the copper is gaining mass and the tin is losing mass, this tells us that SN is actually being oxidized. So this SN solid is changing into SN2 plus. So this is being oxidized. Why? It decreases in mass because it dissolves. It practically is dissolving. It's changing from the solid atoms into the aqueous ions. So it's changing from the solid into aqueous ions. And 2 electrons are lost, while here the copper is being reduced. The copper ions inside the solution here are gaining 2 electrons and form the copper solid. So it's changing from aqueous ions into solid. So this means that it is gaining mass. It's changing into solid that's precipitated on the electrode. How do we know that it's not copper? So how do I know that it's not copper and it is tin that's being oxidized? The copper electrode is getting larger. أنا بزود الماس بتاعه. Why I'm increasing the mass? Because I'm getting ions. I'm taking ions from the solution and changing them into copper solid that sticks to the electrode. This is not oxidation. This is reduction. This is the opposite of the oxidation which is happening here. دايما الناس رغم الجزء ده سهل جدا بيبقى عندهم مشكله لما يبص على الايكويشن, but it is actually very easy. The oxidation is the loss of electron that's happening here, and usually in the oxidation the mass decreases. If you want to memorize it, it will help you. The mass will decrease, and in the reduction it is the gain of electron, and gain of electron I'm making a solid, so the mass will increase. Okay, the next part is asking me in the question number 3, as the mass of the SN electrode decreases, where does the mass go? انت بتقول the SN mass decreases. احنا قلنا where does it go? The solid atoms is changing into ions, and ions dissolve inside the solution. So they are going to dissolve in the solution. These ions are floating around in the liquid, so it will be moving inside the liquid. It's lost inside the solution. Why this is happening? Because they are losing electrons. They are changing from the SN solid into SN2 plus. Okay, that was easy. Number C is in the expanded view. This is the question that we saw last time. This is the question that we saw last time. We said that in the expanded view, this is still question number 3. So he said he drew a portion of the salt bridge showing and draw and label the particle view of what occurs in the salt bridge. What did we say last time? We said that in the galvanic cell, I have a salt bridge and its benefit is to make the charges balance. We said that if you have the negative here, the number of electrons are moving too much and going here. So this is the anode. So let me draw that this time. The cathode here, this is the positive electrode, and the anode is the negative electrode. This is in the voltaic cell. So the electrons will move from the anode and go to the cathode. The anodes move here and here go to the cathode. So there will be a lot of electrons. So there will be a lot of electrons. That's why. And we said the anode, the cathode is the one in which there is a reduction. So this is a reduction, and this is an oxidation here. So there is a lot of negative charges. That's why I have to get some of the ions from the negative ions move towards the SN side. So some of here, now قلنا الأوكسيديشن بيحصل للSN صح؟ قلنا الأوكسيديشن happening to the SN. So this is the SN and this is the copper. البوزيتيف ions must move towards the copper. يبقى الكاتاينز we said last time the cations like the K plus are going to move towards the cathode, and the anions, I will draw the anions, which is NO3 minus, goes towards the negative. Why this is happening? When the positive ions moves towards the copper, it will decrease the negative charge. It will decrease the negative charge. The negative charge, electrons are not tension. Electrons are moving like that, moving like that, moving like that, moving like that. So there will be accumulation of negative charges here. So I need something to balance this accumulation. I have too much negative, 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 negative. So I have to put some positive ions. That's why the positive K ions move in order to balance that negative charge. It will decrease a little bit. يقلل شوية من negative charge that's accumulating here. So that's why it goes here. The negative ions goes here because SN positive ions are formed. You said that SN is being oxidized and changing into SN2 plus. So there is a positive accumulation of charges. So I also need something to go here to balance this negative. يبقى أنا عندي هنا في الكاثود في accumulation للنيجاتيف charge. That's why I need here something positive to balance it. And I have an accumulation of negative charges coming from the electrons. While here the accumulation in the positive charges coming from the SN. We said the SN is being oxidized and forming SN2 plus. So there will be too much SN2 plus here. That's why I need some of the negative charges to come here. And in order not to forget, remember this always. The cations will go to the cathode and the anions will go to the anode. But still you need to explain why. بالك, take care. In the electrolysis, it is the same also. If you remember, in electrolysis it's the same. So always cations go to the cathode, anions go to the anode. If you are in the electrolysis, also the same. Let's remember together. This is a battery, and I have, for example, lead. I have a solution of lead bromide. So lead is here, the positive is called the anode this time, and the negative is called the cathode. So the positive goes to the cathode. So the cations, which is a positive lead, goes to the cathode. So no change. Still the positive goes to the cathode. And like here, the cations also went to the cathode. And also the negative here goes to the negative. So the bromide went to the negative went to the positive. So the anions goes to the anode. The only difference is the names has shifted. So the names has shifted between them. The cation, the anode is positive inside the electrolysis, but it is negative in the electrochemical cell or the voltaic cell, and the cathode is negative in the electrolysis while it is positive in the voltaic cell or the galvanic cell. The next question is asking me if I have a non-standard cell. So if I have a non-standard cell made by replacing the copper nitrate and standard, replacing 1 molar solution of copper nitrate and tin nitrate in the standard cell into 0.50, and both of them كان عندي يا مستر in the beginning it had standard. What does it mean to being standard? So it has 1 molar and 1 molar. Now the new one will be, instead of 1 molar and 1 molar, will be 0.5 and 0.5. The volume here is the same as the volume here, and the rest of conditions is the same. Is the cell potential of the non-standard cell, which is E, is the same as E node, or equal, or bigger than? We have always to see the ratio. So I have always to see the ratio. Does the potential difference change or no? Does the potential difference change or no? The cell potential will stay the same because the ratio of the ion concentration in the reaction remains the same. So if you looked at the concentration of the products, which is the nitrate, let's look at the equation. In the equation, the copper has gained electrons and formed copper solid, and the tin has lost electrons and formed tin ions. And there is 2 electrons here will be cancelled with here. So I have the aqueous here as 10 over copper. So I will say that the concentration of the tin 2 plus over the concentration of the copper 2 plus. Does it change or no? Mr. The ratio is the same because here it is 1 over 1 molar over 1 molar, and here 0.5 molar and 0.5 molar. So if you have the ratio is the same, so concentration of 1 to 1 and 0.2 to 0.5, this means that the Q is the same. So this means that the Q is the same. So the Q here is equal to the Q here. If the Q here is equal to the Q here, because the concentrations are equal, then you will have the E cell equal to the E node of the cell. We have the E cell is equal to the E node of the cell. Simply, Mr., you are saying that the E in the cell, so simply you are saying that the E cell اللي هي non-standard conditions is equal to E node cell with the standard conditions minus RT over the number of electrons multiplied by F multiplied by the length of Q. So this all the same, and this all the same. So this one will be equal to this one, okay? I did not change the Q. I did not change any value here. So these values is equal to this value in the same way. Okay, let's see the next question. He said both the standard and he said both. Screenshot it again. Okay, copy. Yes, finally. Both the standard and non-standard cells can be used to power an electronic device. Would the standard cell power the device for the same time, a longer time or shorter time? So أنا عملت battery, I made a battery, and this battery is made with an electronic used in an electronic device. وقلت الباتري دي يا مستر واحدة فيهم معمولة الكونديشنز ستاندرد كونديشنز يعني 1 مولر و1 مولر، والتانية هتبقى 0.5 مولر و 0.5 مولر. هل يا مستر البطارية ديت هتفضل شغالة بنفس الوقت زي البطارية التانية، ولا is this going to give the same time working as a battery or shorter time and why؟ مستر النون ستاندرد اكيد هتكون shorter time. ليه يا مستر؟ ليه؟ عشان الكونسنتريشن بتاعت الكبر ايونز اللي بتعمل الرياكشن كلها will be less. You have the concentration of copper ions that's being reduced and changing into copper solid is less. بدل 1 molar copper you have instead of copper 1 molar you have copper 0.5 molar only. So this means that the supply of the copper will be finished faster. So it will be finished faster. When you have lower concentration, 0.5 instead of 1, you start with fewer ions. So what happens when the ions finish? The cell does not make any more electricity. So here this is the power. This is the power, and this is your cell. As long as you have, you said the Sn is the positive and the copper here, the copper ions in this one are being reduced and form copper. What happens when the copper finishes? Once it finishes, there will be no more electricity. طب Mr. I have here 0.15 and here 1 molar. That's why it will have shorter time. It will work for a shorter time. بعض الناس بتهيألهم, some people think that as long as I have the same voltage, we said that the E node is equal to E. ناس بتقولوا طالما I think I have the same voltage, so it will be the same running time. No, of course, it's not the same. If you don't have the same concentration, so it will not make the same running time. The running time depends on the amount of the substance or the amount of ions. If you have less material or less ions, it will, يعني lower concentration, it means you will reach the equilibrium faster. So it cannot move any more. Right. Number E, I have another experiment. In this experiment, the student راح جايب new SN electrode. So he brought a new SN electrode وحط solution جديد من الكبر nitrate and then put a new solution of copper nitrate. Using the information from the table above, write the net ionic equation for the reaction between the SN and copper nitrate solution that will be thermodynamically favorable. ايه الحاجة اللي هتكون thermodynamically favorable يا مستر علشان خاطر الرياكشن تحصل. In order for the reaction to happen. Mr. What is the reaction that you have originally? We said that the copper is reduced and the tin is oxidized. So this one is solid. Change it SN2 plus aqueous, and this one change it into copper solid. This is the equation. So this is the equation that will use this ionic equation that will be favorable. Why this one is favorable? Why this is thermodynamically favorable? Because when you do this one, what will be the values? The copper 2 plus is changed into copper means that it is reduced. So it is 0.34. And the SN changes SN2 plus. So the opposite of this one, SN2 plus our SN. So it is the opposite of this one. So it will be 0.14 with a plus value. So 0.34 and 0.14, it is 0.48. That's why it is plus 0.48. It is positive E node. As long as you have a positive E node, so delta G is negative. So this means it's a favorable reaction. طيب لو أنا كنت جربت حاجة تانية, if I tried something else, now some students forget to flip, صح؟ بيقولوا لا يا مستر it will be 0.34 and 0.14. Luckily, he didn't ask us about the numbers. So even if you said 0.34 and you said it is negative 0.14, it's going to positive 0.20. It's going to work. But if he asks you about the numbers, of course, it will be wrong. Now, don't forget to flip one of them because one of them has to be oxidation and the other one reduction. You cannot make both of them reduction in the table like that. He will ask me what is the value of the delta G. By the way, in the mark scheme, he's saying that he needed the calculation. So he needs the correct calculation. So if you do this one, you will not get the full mark. So you get 2 marks because you need your justification. If you said that it is working and it is favorable and you did not give the correct numbers, you will get 1 mark out of 2 only. So you need the correct justification. You need to make sure that you are using the correct ones. بستخدم ده. No, I don't use the copper plus 1. I use the copper plus 2 because you lose 2 electrons and you gain 2 electrons. I cannot use this one and I cannot use this one. And I didn't say that I have SN plus 4. And don't forget to reverse to get the correct number. Otherwise, you will not get the second one. Okay, if I want to find the delta G for the reaction, including so you just said that delta G is equal to minus NFE. What is the number of electrons lost and gained? It is 2 electrons. So 2 electrons multiplied by fixed value 96485 multiplied by the E node. Oh, if I didn't get the correct answer, how I will answer this? So it is 0.48. So it is 0.48 multiplied by negative 2, which is the number of electrons gained or lost. So it's equal to minus 93,000 joules per mole. 93,000 joules per mole. And he wants to find the answer also in G will be better in kilojoules, so it is negative 93 kilojoules per mole. Okay, so let's try to fast remember important things about this question. First thing, the oxidation will happen when the mass is lost. So if I lose mass, so this is oxidation. If I gain mass, this is reduction. Why, Mr.? Because here you are changing from the solid into ions. So we change it into aqueous. So basically your solid has dissolved, and here the copper ions has changed it into copper solid. So basically you have solid being precipitated, which means that it is increasing in mass. Don't forget the salt bridge benefit. It moves ions, not electrons. It is used to balance the charge. It is used to balance the charge. So the cations, which are positive charge, go to the cathode. So it goes to the cathode. So it goes to the cathode. Why? Because this is a positive here will be accumulation of negative here. So there will be negative accumulation, so it tries to balance it, and the anions go to the negative. What does the anions go to the negative means? It means it goes to the anode. Why? Because there is accumulation of positive ions. Don't forget, here there is accumulation of electrons, and here accumulation of positive ions. Let's see the next question. طبعا positive, we know that positive potential, positive delta E is equal to a negative delta G. That's for sure, very easy. And running time of any battery depends on the concentration of the material that I have, not on the potential difference. Not on the potential difference. يبقى مش معنى ان انا عندي بطارية البطاري ديت مثلا 1.5 volt and this battery is 3 volt and this is a small battery and this is a very big battery. Which one will work more? Mr. This one, even if it is 1.5 volt, the potential difference بتاعها قليل, and voltage is small, but it is very big battery. A very big battery compared to this one. So this one is very small battery. Although it has a higher potential difference, it will have a lower run time. البطارية بتاعتي أصغر بكتير, هتشتغل معايا وقت أصغر ما البطارية دي هتشتغل قبل ما تخلص. Okay. I think we can stop at this question and we'll continue from the next time. Let me stop here because we don't have enough time to finish the next question.